In this final video on the financial aspects of PV and PV systems, I will discuss the various financial incentives for PV. How can we pay owners of PV systems? Let us dive into the topics we are going to learn today and answer these questions together. There are different schemes to compensate owners of PV systems for electricity they deliver to the grid. We will discuss two such schemes, feed-in tariffs and net metering. These policy-related factors can strongly affect both the initial investments as well as the savings over time. We will then look into ways on how PV is subsidized and to other alternative mechanisms to finance PV which are not necessarily seen as incentives. Let us briefly discuss the concept of feed-in tariffs in PV systems. The feed-in tariff is the rate that the consumer is paid for the electricity that a grid-connected PV system contributes to the local grid. There are two kinds of feed-in tariffs, namely the gross and the net tariff. The gross feed-in tariff is the amount paid for all the electricity generated by the PV system, regardless of the electricity consumption of the PV system owners. The net feed-in tariff is a higher rate. This rate is paid for the surplus electricity fed into the grid after subtraction of the domestic consumption. Feed-in tariffs are just a price that you pay the PV system owner for how much energy they generate. This price can be above, below, or equal to the retail market value, and there are different reasons why you would want to do any of those. Now, we have to have a separate meter. If you look at the PV system here, we have the house and the PV system. Both the house and PV system connect to the grid through a bidirectional meter that goes to the grid and tracks how much energy is being consumed and how much energy is being produced. But now we need to add a separate meter to read how much energy the PV specifically is putting into the grid. When we add PV, we have to add extra costs when considering grid connections. They can make feed-in tariff lower than the retail energy costs. So if it costs X cents per kilowatt hour to consume energy, we're only going to get less than X for every kilowatt hour we produce because there are extra charges to connect the PV system to the grid. If the government specific to your country wants to support PV and penetrate the grid with PV, feed-in tariff might be higher than the kilowatt hour price of retail values, which again depends on the incentives that the government supports. For example, in Germany, grid penetration is increasing at a very high rate, which then leads issues to grid connection, and therefore the German governments have subsequently lowered the feed-in tariffs relative to retail energy costs. If an area is aiming for higher PV penetration, then the feed-in tariff will increase for that particular location. In households with PV systems installed, the electricity consumer will also become an electricity producer who wants to sell excess energy to the grid. Hence, the consumer is turned into a producer/consumer of electricity, or some people call this a prosumer. When feed-in tariff is adopted, the financial burden falls upon the consumer. In this case, the consumer would definitely want an accurate estimation of how many kilowatt hours they are going to produce. The price paid can exceed grid electricity, but it can also be less. For such a system, two electricity meters are necessary. One measures the power consumed from the grid, and the other measures energy delivered to the grid. Feed-in tariffs stimulate the installation of renewable electricity technologies, such as PV, if the feed-in tariffs are above the electricity price. On the other hand, if they are set slightly below the electricity price, self-consumption of the PV system can be stimulated. If the feed-in tariff is low enough, this can encourage prosumers to install storage, enabling them to consume all the energy they produce, since selling it back to the grid is no longer financially advantageous. Now let's discuss the second type of compensation scheme called net metering. Here we do not have a separate meter. We only have one meter connected to the house and PV. All the PV which is generated goes to the grid, and every load consumes from the grid. The meter rotates in one direction during net production and the other way during net consumption, and the utility company only sees the net result. Net metering is basically like a feed-in tariff, with the distinction being that it sets the feed-in tariff at exactly the same price as retail energy. In net metering, the price paid by the utility is the same as the price charged. Old-fashioned electricity meters which operate in both directions are used, but nowadays smart meters are used which can distinguish between electricity consumed from the grid and electricity delivered to the grid. Such a system is interesting for consumers if the levelized cost of electricity of the PV system is lower than the price paid for electricity from the grid. Now you know about the difference between feed-in tariffs and net metering. Let's shift gears and talk a bit about mechanisms to finance PV systems. We are going to look at three such mechanisms: solar renewable energy credits, power purchase agreement, and solar leases in detail. The solar renewable energy credits, or SREC, are already implemented in some countries. In SREC, the target of renewable energy production or consumption is set, and the utility is obliged to purchase renewable energy or else a fine is charged. The producer, in turn, is then credited with the SREC for every 1,000 kilowatt hours of electricity produced. If the homeowner owns a 5 kilowatt system, and the system now generates 5 solar renewable energy credits per year, now each of those SREC is sold to the utility for, let's say, 200 euros. Then, in this example, the homeowner owns 1,000 euros per year, which is in addition to the savings achieved on their electricity bill. Another mechanism is the power purchase agreement, or PPA. In PPA, initially, an agreement is reached between the customer and the PPA provider. The PV system is then installed by the PV provider. The installed system now generates energy for the customer's building, for which the customer pays a predetermined energy price. The PPA provider therefore owns, manages, and maintains the PV system. The rates for which are fixed for a time period of somewhere between 10 and 25 years. Customers can now enjoy low capital costs and pay only the electricity of their PV systems generate. In some cases, customers cannot directly benefit from a PPA program since the end of the energy produced must be sold to the local utility. In these cases, another mechanism known as solar leases are attractive for facility owners because it is now possible to generate revenue. The facility owners lease areas of their property such as rooftops, parking lots, and even open lands, which can now be developed for hosting PV systems. The owner of PV system designs, finances, installs, and even operates the system. The facility owner therefore receives lease payments that can either be paid on a scheduled basis or a single lump sum. This option benefits the facility owner to convert the cost centers, such as rooftops and parking lots, to revenue generators without any capital investment throughout the lifetime of this project. With this last video, we conclude the course on photovoltaic systems. In this series of lectures, you learned about the economics involved with PV at several levels, such as the consumer level, the manufacturing level, the level of PV installers, and the technology level. PV has been compared to other electricity generation technologies from an economic point of view. I hope this course has helped you to understand the various concepts and challenges faced by a PV system. The Knowledge of PV Systems course will help you to further understand the design and structure of a microgrid. I hope to see you back in the next course of the MicroMasters of Solar Energy Engineering.